Sound. Here are your priming questions. For sound, it always starts somewhere. For sound, it starts with the vibration of a material object. If you think of the different instruments that we have, if you have a string instrument, it'll be the string itself, so the guitar string for a guitar. For a woodwind, it'll be the reed. For a brass instrument, it'll be the column of air through the embouchure of the lips. And then for our voice and for singing, they're the vocal cords for us. And this is where the sound starts. From there, if that were the only vibration to create the sound itself would be very soft, and in fact, it would be very hard for us to hear it. And so in order for us to be able to hear that sound, that original vibration will then transfer to something larger. And so if you think of a guitar, the face of the guitar is actually a sounding board. And if you ever look at the guitar strings, there's usually a piece of plastic, a nut typically, that the guitar strings are positioned against, and that is what transfers the sound from, or the vibration from the guitar string to the sounding board of the guitar. If you think of other stringed instruments, they'll have a bridge, and that is what transfers that vibration to the sounding board of that instrument. And if you think of a wood instrument, the column of air is what is then initiated into vibration, what creates the sound. So it starts up here in the reed, and then through the entire instrument, through the air in the instrument, the sound is larger. And then for us, when we talk and when we sing, the air that is in our throats and in our mouth is what forms into the larger sound. It creates a greater vibration through the use of that. Now, the frequency of the vibrating source is equal to the frequency of the sound waves that are produced. This is what we call the pitch. So whatever the frequency of the reed or the guitar string or of your vocal cords, that's going to be the sound that you hear ultimately from the sounding board or from the column of air. It's the same frequency or the pitch. Now, on average, most people can hear pitches from 20 hertz to 20 kilohertz. And this is what we call our acoustic range. There are greater ranges than this. So if we go below 20 hertz, this is what we have defined as infrasonic. And this is actually the range that elephants communicate at. And then we also have ultrasonic, which is above 20,000 hertz. And this is the frequency that the bats use. And now you want to be careful with this. This is not the same as supersonic. Supersonic is different. The infrasonic, ultrasonic, and our acoustic range, these are frequencies of sound. When people talk about supersonic, this is talking about speeds or velocities. So it's going to be very different. We'll talk about that in a little bit. Now, we have what's called the Doppler effect, which you've probably heard the term Doppler before, either with, most likely with weather, actually. And it is the same exact Doppler effect. And this is caused by a change in pitch due to the relative motion of the source and or of the receiver. So as a quick example, if the source moves towards you, the pitch is going to go up. If the source moves away from you, the pitch goes down. You've probably heard this before as a car is honking its horn coming towards you and then goes away from you. You've probably heard the change in the pitch. We're going to talk a lot more about the Doppler effect in a subsequent video. So here are your primary questions again. Don't forget to answer these.